Hey people, let's talk about shaders. Now, unless you're making a top-down ASCII art kind of game, you probably already have a degree of familiarity with them. Now, I'm no GPU engineer and my salary certainly reflects that, so I can't tell you what black magic is going on in your 1070 that makes it work. But I like to imagine that I can provide you with a good enough understanding of how shaders work. So this is going to be a two-parter. In this episode, we'll first talk briefly about GLSL, OpenGL's shader language, which, if you squint at Unity's HLSL and Godot's shader language, you really can't notice a difference. And then we'll yap about the graphics pipeline from a general perspective. Then, next episode, we'll dive deeper into GLSL by covering a few examples. And I'm doing it this way because I demand you ask questions for the next episode. You want to know how to do cell shading? Ask it. You want to know how to do vertex animations? Ask it. Either ask it in the comments, email, Discord, carrier pigeon, whatever. Just get them to me by Friday, December 13th, or I just won't have time to address them. If you're interested in learning these things for yourself, check out Learn OpenGL by Joey DeVries. It's a great learning resource that provides C++ and GLSL examples. Alongside the website, there's a PDF you can download for free and a dead tree version you can buy if you're into that kind of thing, like myself. One more thing, depending on what you're trying to do with shaders, they can be very math heavy, what with all the vectors and matrices involved. And wow, would you look at this? A video covering vectors and matrices. Crazy, right? So if you need a refresher on linear algebra, why not give this a blast from the past a viewing? See the description for links to both. So we'll briefly cover GLSL because I think if you're comfortable programming, it's a genuinely easy language to just pick up by using it. I don't really know what to say, just look at it. It looks like C. Hell, it even has main as the entry point of the program. It even has C-like macros, functions, structs, but no classes, as God intended. It's a C-styled, not C++ styled language after all. And while you can use if, else, while, and for control flow, since this is running on the GPU, it's very discouraged. It's basically C, but for graphics, and for me, the real standout differences stem from that fact. So, vectors and matrices are built-in types, along with all the operations you expect and a healthy standard library of functions for them. Add two vectors together to get the element-wise sum of them. Multiply two matrices to get the matrix product. On top of those sensible things, you can also swizzle vectors, meaning you can select specific indices from vectors to create a new scalar or vector. Want a float that's just the y element of a 4D vector foo? Just write foo.y. Want a new 4D vector that's the x, z, then x, and finally y vector of a vector bar? Write bar.xzxy. Along with the vectors and matrices, there are also built-in types for sampling images. I think the other standout difference are the keywords in, out, and uniform. In, out, and in-out are used to clarify how parameters are used inside of their functions. In means the parameter is passed by value, so it's free to be used and modify inside of the function, but any modifications won't be visible outside of the function scope. Out means the parameter will not be set by the caller and instead be set inside of the function, meaning the changes will be visible outside of the function scope. And finally, in-out is just like passing by reference. For passes, in and out have the same meaning, but the uniform keyword means that variable can be read and set by all passes and can even be set outside of the shader program. And that's basically it. Once you start using GLSL and reading the docs, it's a super straightforward language. I've provided links to both the language documentation and the standard library function documentation in the description. And as I said earlier, Unity and Godot are basically also using GLSL for their own shader languages, because they're also both using OpenGL. Both of them have good enough documentation covering their own house blends, but aside from some new keywords, functions, and macros, it really is the same language. So, the big question. How do we get from data to graphics? The render or graphics pipeline. And the pipeline begins with vertex data. Then that raw data is modified by the vertex shader. The vertex shader outputs a 3D position for each vertex, which is turned into a shape during shape assembly, usually triangles. the geometry shader changes the basic shape assembled into something else. This step can be skipped, but if you're using tessellation to add detail to your models or are generating completely new geometry, the geometry shader makes it happen. Next, the shape or shapes created by the geometry shader are converted to pixel positions via rasterization. Then the fragment shader determines the color and transparency of all the rasterized pixels. Finally, all the pixels are tested against each other and blended for your desired look. And that usually includes making objects in front of other objects drawn in front of other objects. Now, where else to start but the start? Vertex data. If we look at a model in Blender, we can see it's composed of corners, aka vertices, the edges connecting them, and the faces between them. Vertex data at the bare minimum is the 3D position of the vertices, but it also usually contains one or more 2D texture coordinates created during UV unwrapping, its 3D normal, vertex color, and sometimes even vertex tangent and bitangent data. All of this is just shoved into one big float array, but then your engine, or you, instruct OpenGL which elements to look at for each doodad in the vertex data. This is all passed to the vertex shader. The vertex shader has to provide a new 3D vector for where the vertex quote-unquote should be. This usually entails converting the local vertex position in the vertex data to the clip space vertex position using the model view projection or MVP matrix. The MVP matrix is the matrix product of the matrices that transform a vector from local or model space to global space, then global to camera or view space, and then finally from view to normalized device or projection space. And since matrix product is associative, the MVP matrix does all of those transformations in a single operation instead of 3. Now, if you're an avid fan of my previous work, you may be asking, why aren't we using quaternions? After all, a quaternion is just 4 floats, whereas the MVP matrix is 16 floats. That's 4 times the bandwidth. You can use quaternions if you want, but the MVP matrix is more convenient since there are functions that make it expedient to use and there are decades of work built on it. You can also pass along additional vertex data or create completely novel vertex data for use in future steps. Next, shape assembly. If you remember what I rattled off what's typically in vertex data, I did not include information regarding edges or faces. That's because along with the vertex data, there's usually also an array of indices that instructs the shape assembly how to build each triangle. And lacking that, it just builds a triangle out of every 3 verts. So, if we wanted to draw a square composed of 2 triangles using just 4 vertices, we'd first give it the 3 indices to create the first triangle, then the next 3 indices to create the second triangle, for a total of 6 elements. As you can see, there are repeating indices, but that's because we reuse vertices to create the 2 triangles that compose the square. And while shape assembly is out of our control, we get it back during the geometry shader. The geometry shader takes the vertices of the primitive shape generated during shape assembly, and then you can just do whatever you want with it. Feel free to add more vertices or just get rid of all of them. Whatever, you have control. Since the geometry shader programmatically alters geometry, it is great for adding tessellation to dynamically add details to models or generate geometry like foliage and even animate it. After all, you can sample textures during all shader passes, and that includes the geometry shader. Next, rasterization. Jesus has taken the wheel. Basically, zero control here, and that's a good thing. And then the last step, we have full control. The fragment shader pass. Since the frag shader runs on all rasterized pixels, it interpolates data it gets from the vert and geometry shaders. This is why vertex lighting looks the way it does. Whereas lighting typically gets calculated in the frag shader per pixel, vertex lighting calculates the lighting during the vert shader per vertex, which then gets interpolated per pixel during the frag shader. As I said earlier, this is the step that determines the color and transparency of each and every pixel. So, sample your albedo, normal, and roughness textures here. This is your last chance, so make it look how you want it to look, because after this, it's pins down. And finally, testing and blending. Again, largely no control, but you can influence which tests are performed and how things are blended. Think of setting transparent objects to blend additively or multiplicatively. That's what you get. And that's it for this episode. I hope this quick overview left unanswered questions because I want you to ask them for part 2. As I said earlier, ask me your questions by the auspicious Friday the 13th of December 2024 on Domini, and I'll do my best to answer them. You have some time to marinate, but not forever. As always, thank you for watching. I appreciate your time, and I hope you have a good day. If you enjoyed the video, maybe even learned something, please give it a like. And also, subscribe for the next episode, which will actually dive into details and answer questions. Speaking of questions, great way to ask a question, leave it in a comment. I read all your comments, and I will be monitoring them for questions. Another great way to ask a question, Discord. The channel has a server you can join, and you can ask your shader questions there. Or just DM me, I don't really care. The link to the server is of course in the video description. I also have a Twitter, but do not ask me questions there. I log into it about once a month tops to unfollow all the bots that follow me. So you will go unanswered if you ask on the Bird app. Speaking of Bird, we just had Thanksgiving here in the States. A lot of food and a lot of baking. And speaking of baking, let's get to it. Oh man, so last time also a galette, and apparently this started me off on a galette tear. I really have just been once I start making galettes, I always remember like, wow, this is so easy. Why don't I make them all the time? So this is why we have some more galettes. And as you can see, I got a bit of leakage on this apple galette, but it happens. It happens. It's still edible. It's still delicious. And this time I think, it looks like I just used Granny Smith apples for this one, which worked out really well. I enjoyed the tartness, I think, going forward, I might do a blend of Granny Smith and Honeycrisp, but just Granny Smith works out just fine. Not as good as the blend. I'm gonna go with the blend going forward, and oh man, I forgot. I forgot. But my last camera, something happened to the camera after Japan. Probably something to do with I think moisture got in one of the lenses, and it was always kind of bloomy. So that's why there's so much bloom on these pictures. But next one, not only did I make a apple galette, I also made a blueberry galette, and for this one I just used I want to say frozen blueberries, and yeah, there might be some stems in there still, but it's just a little extra fiber, kind of balance out all that sugar. So this is actually a terrible angle of the blueberry galette. Let's switch to this photo, and yeah, gorgeous. Yeah, that's not that heavenly glow. Again, that's just some moisture in my camera lens. But yeah, I mean, galettes, super easy. Again, frozen blueberries. Are those stems? I might have to double check. Oh no, that's not stems. Never mind, not stems. That's lemon zest. Totally not stems. Totally not stems, boys. And yeah, I do have. So yeah, this is totally not stems, boys. This is professional. No stems here. This is lemon zest. Sorry, the first photo was just hard to tell. That's why I was like, what is this? And honestly, at the bottom of the bag of frozen blueberries, you get some stems. It's fine. It's edible. It's not gonna kill you. Sometimes in the mornings when I'm making my oatmeal blueberry oatmeal with some of my homemade Greek yogurt. That's actual, I've been making yogurt pills. You get some stems first thing in the morning before my coffee. I'm just gonna eat them. That's just how it is. But next picture, and here's another one of the apple galette. Just a kind of different angle. I don't know why I closed the top. Oh yeah, that's totally lemon zest. Huh? Oh yeah. That's definitely lemon zest. definitely it's lemons and yeah, totally. It's much. Yeah, I don't know why I didn't notice in the first one, but yeah. And you use a little extra lemon because again, there's sugar in it. You gotta balance it out, and it's tasty. What can I say? I like lemons. I enjoy lemons. I enjoy limoncello. Also, not only limoncello, but limoncello La Croix. Perfect. Honestly, that's my favorite flavor of La Croix. And don't come at me. If you don't like La Croix, I don't want to hear it. In this household, we like La Croix. But yeah, Galettes, love them. So anyways, I'm going to use the classic sign off. Again, no yeast, but I am absolutely, no sense of shame. Completely shameless. Anyways, the yeast in the air is free. So go out there and bake. It's nutritious. It's delicious. It's good for you. And it makes a great gift. And it's a great way to show people you appreciate them. And again, we just had Thanksgiving here in the States. And again, not only do I appreciate you, I'm thankful for all you, everybody tuning in and watching me. Honestly, it feels like half of this is me just rambling about some stuff. I never feel like I do any topic justice. So, I cope by saying, I hope my shortcomings have inspired you to learn by yourself. Really, this whole channel is, trying to demonstrate that not only can you learn math and game dev or even baking, you can learn anything just by practice. I didn't start out, my first loaves of bread were terrible. And yet here we go. I mean, we'll go back to that beautiful side angle of that blueberry galette. I ended up being able to make this. So again, and yeah, it's not always going to work out your first try, but just pick up, dust yourself off, and try again, and you will improve, and you will learn. Anyways, I'm rambling, but I guess I will see you next time.